Okay, welcome back again. We are discussing a new concept, that is beta and gamma functions. Previous, for the basics for the beta and gamma function is you need the basics of already whatever the integration method you have studied. What is extra we are doing is here the functions which you cannot integrate by using known methods are solved by using beta and gamma functions. Why these are famous? Because whatever the integration method you have used for different kind of functions, right? Which function you unable to integrate, those kind you can solve by using beta and gamma functions. So what is the definition of beta? Of m comma n for two variables or two parameters, integral runs from 0 to 1 x raised to m minus 1 into 1 minus x whole raised to n minus 1 into dx. Here m and n are numbers which are greater than 0. And what is gamma? Gamma is, we are writing in this order. Just look at, this is gamma. Don't write gamma in this form. This is small gamma, this is capital gamma. Gamma of n, you can write for m or n, it is not a problem. Integral runs from 0 to infinity. This is 0 to 1, this is 0 to infinity. E raised to minus x into x raised to n minus 1 into dx, and here n is greater than 0. These are the two standard types, and we have another two standard types. I am going to express first them, then we are going to discuss some properties based on this. I want to express what is the equivalent notations or alternate forms of beta and gamma. These are standards. You have to remember these as it is. Why again these are important is we are going to solve an integration by converting into beta, by converting into gamma. If you convert it in terms of beta, again beta is again converted back into gamma function. There is a relation for us. There is a relation here. You can able to express beta in terms of gamma functions. We'll discuss them later. First, we are going to express the standard forms, alternate standard forms of these two. By observing this, you will come to know very easily that since it containing 1 minus x, by using the identity you people already aware, by substitution of x equal to sine square theta, 1 minus sine square theta becomes cos square theta. Therefore, what is the standard substitution I am doing for the first one? Substitute x is equal to sine square theta. Hope you understand. We are substituting x is equal to sine square theta. Differentiate this. We will get dx. Differentiation of sine square theta is 2 sine theta. Again differentiation of sine theta is cos theta into d theta. Differentiation of sine square theta nothing but x raised to n. X raised to n is n x raised to n minus 1. Again by using chain rule, differentiate sine theta is cos theta. And we need to change the limits of integration. These are from x runs from. When x equal to 0, look at here. When x equal to 0, what is theta value? Substitute here, 0 is equal to sine square theta. 0 is equal to sine square theta. I will write sine theta. This 2 comes to left side, it will become square root of 0. Again 0 only. Sine which angle is 0? Sine which angle is 0? Sine 0 is 0. So sine theta is equal to 0. So therefore theta becomes what? Theta becomes 0. Okay, when x equal to 0, theta equal to 0. Similarly, when x equal to 1, substitute here. 1 is equal to what? 1 is equal to sine square theta. Square comes to left side, it will become square root of 1. Square root of 1 is 1 is equal to Sin theta, sin which angle is 1? That is called pi by 2. Sin pi by 2 is equal to sin theta. Therefore, theta is equal to what? Pi by 2. Hope it's clear, right? So therefore, the given beta gamma function becomes beta of m comma n is equal to new values theta runs from 0 to pi by 2. And what is the value of x you have taken? Sin square theta whole raised to m minus 1, okay, into 1 minus sin square theta whole raised to n minus 1 into what is the value of dx? 2 sin theta into cos theta into. Okay, now look at integral runs from 0 to pi by 2. This is sin theta whole square. Usually we write sin square theta as sin theta whole square. Sin theta whole square means 2 will be multiplied to m and n. It will become, you can write sin theta whole raised to 2 into m. 2m minus 2. Isn't it? Again there is one more sin theta here, right? You can write sin theta whole raised to 1. Sin theta is same as sin theta whole raised to 1 also. Similarly, what is 1 minus sin square theta? Cos square theta. Cos square theta again by multiplying m minus 1 becomes cos theta whole raised to cos theta whole raised to 2m minus 2. Again one more cos theta here you have into d theta. There is a constant to take outside. This I am written 1 minus sin square theta is cos square theta. I am writing here once again, just look at. This is cos square theta whole raised to n minus 1. This is same as cos theta whole square whole raised to n minus 1. You can multiply this. This will become cos theta whole raised to 2 into n is 2n minus 2. Okay, it's clear? Here I have applied this formula. You people already a raised to m whole raised to n is a raised to mn. Law of indices formula. Okay, fine. Now you can combine sin theta whole raised to 2m minus 2 and sin theta whole raised to 1. Bases are same, powers are added. 2m minus 2 plus 1. 2m minus 2 plus 1, how much? 2m minus 1. Sin theta whole raised to 2m minus 1 is also same as, that is b of m comma n is equal to 2 times of integral runs from 0 to pi by 2. This will become sin raised to 2m minus 1 theta. Or you can also write sin theta whole raised to 2m minus 1. Both are same only. You can also write this is same as sin theta whole raised to 2m minus 1 also. Again here also cos theta whole raised to 2n minus 2 cos theta whole raised to 1, isn't it? Bases are same, powers are added. It will become cos raised to 2n minus 1 into theta into d theta. This is the second or equivalent form of beta of m comma n. We are using those most of times while solving the examples. So that is the equivalent notation. Let us express the equivalent notation of gamma function. This is beta, this is gamma function. In gamma function what we are doing is, we are substituting, not substituting like x is equal to sin square theta. Here I am substituting x is equal to t square. I am substituting x is equal to t square. You can differentiate it, dx is equal to what? 2t dt. Right? Now you can change the limits of integration. When x is equal to 0, this is x equal to 0. Default it is x equal to 0 because integrand is x. When x equal to 0, what is the value of t? t is also 0. When x equal to infinity, t is also infinity only, because square root of infinity is again infinity only. So the new values becomes gamma of n is equal to integral runs from 0 to infinity again, but new variable is t here. Previously it was x, the new variable is t. Now you can concentrate e raised to minus t square. What is the value of x? X value is t square whole raised to what? N minus 1. What is the value of dx? 2t into dt. We have substituted x equal to t square dx is 2t dt. Fine. You take this 2 outside. T runs from 0 to infinity. Right? Okay. You keep it e raised to minus t square also as it is. This is again same formula I am applying. T square whole raised to n minus 1. T square whole raised to n becomes t raised to mn, like a raised to mn. It will become t raised to 2n minus 2. There is one more t here, right? Okay, how much or what is the final value? Can you please? E raised to minus t square, t raised to 2n minus 1. Bases are same, powers are added. 2n minus 2 plus 1 into, this is the alternate formula for gamma. You remember, this is first one, this is second one. Equivalent notation of 1 is this 3, right? Equivalent notation of 2 is 4. 1 and 3 are same. 2 and 4 also. 2 and 4 are also same. So if you find any difficulty, you please feel free to ask.